All right, guys, we are covering lesson 8 today over circles. So, new territory here. This is going to be a lot of brand new information. The biggest part I want us to focus on is everything on this first page. Okay, all this first page stuff over central angles and some of the vocab we're going to talk about up here. Okay, if you make it through that, that's going to be ideal. The other side is going to be, this is also important. This is something called inscribed angles, but I'm going to consider all of this bonus content. So if you make it through the first set and you feel really good about it, then go ahead and try to do the inscribed angle section too. Now, I did decide to cut out this part and this part. It is important information, but it's not covered really on the practice sheet, so you don't really need it like to do the practice problems, so just don't worry about that part for now. But let's go ahead and dive in here. Okay, so there's a lot to learn about circles, and maybe you have learned some things about circles already. I wrote out just a short list of some vocab. There is more vocab when it comes to circles, but this is going to be some of the relevant stuff that we're going to use today. Okay, this is not anywhere close to everything you'll learn about circles. So when I looked at the circles unit, I pulled what I think to be the most important foundational pieces of circles and decided to teach those to you. So if you go into this year knowing a little bit about central angles and maybe also inscribed angles, then you'll be in a really good spot to learn the rest of the stuff about circles. Okay, so what I did is I just drew a circle up on the top of your paper so that we could look at it and maybe identify and draw in some of these vocab pieces here. So the very first one is the center of a circle, and that's the easiest, right? Well, maybe drawing of the very center is kind of challenging, but it's about right there. Every circle has a center, and it's usually going to have like a letter next to it. So let's call this circle A. Okay, and what they'll do is they'll literally call this circle A, and that is the notation they use. They literally draw a circle with a little dot and then name it by that point in the middle. All right, so we've got circle A here. How about what a radius is? I'm sure a lot of you guys remember this. A radius is going to be a line segment that extends from the center to the edge of the circle, and you can draw that infinitely many ways. You could draw it from here to here, here to here, over there, there, right? And it's important to note that every radius you draw is the same length because they all come from the very center. So let's draw a radius here. Let me get my drawing tool and let's maybe draw it, I don't know, pick your favorite spot. Let's go up here. I'm just kind of anticipating all the other things we're going to draw. Okay, so there's our radius, and if you want, go ahead and label it off to the side somewhere. This is a radius. Oh, I'm still using my tool. Radius. Okay, let's talk about what a diameter is. So a diameter is, if we took this radius and we extended it through the circle and landed on the other side, that full length is a diameter. So a diameter is twice the length of a radius. And you could draw a diameter anywhere. You could extend that and have a diameter. You could draw one here. You could draw one here, or as long as it goes through the center, which that one did not. Those are all diameters, and all diameters are the same length. They must go through the center for it to be a diameter. So let's draw an example of this. I'll just go side to side. Let's say we start here, go through A, end over here. Okay, so there's a diameter, which, I mean, we could label that too if we want. If you want to do that, go for it. Diameter. Okay, it looks like it's pointing to the radius, but we're talking about the entire green line I have. All right, let's talk about our next word, which is a chord. Now, a chord is just a line segment. This is probably a new one for most of y'all. It's just a line segment that has endpoints on the circle. It doesn't necessarily have to be going through the center. It can be drawn anywhere. So let me show you an example. Like if I put a point here and a point here and I connect those two, that would be an example of a chord. Okay, just any segment in the circle with its endpoints on the edge of the circle itself. So let's maybe label that out to the side. That is a chord. Okay, so by that definition, a diameter is actually a chord, right? Because it's got endpoints on the circle and it's a segment. It's just a special kind of chord that we give the name diameter because it specifically goes through the center. All right, now the last one I want us to look at is something called an arc. So an arc, this is probably new as well, that is basically a piece of the outside of the circle. If you remember, the entire outside length of the circle is called the circumference. So an arc, you could say, is a part of the circumference of the circle. So this would be an arc, right, from this point to this point. I could also say I have an arc from here to here. There's an arc. I could say I have an arc from here to here, okay? And FYI, if you add all of the arcs together, it comes full circle, that equals 360 degrees. A really good fact to remember for that, okay? So if it comes full circle, it's 360 degrees. So you could see that whenever you have a diameter from endpoint to endpoint, how much do you think that measures? Well, it's going to be half of 360, so that's going to measure 180 degrees. So that's a good one to keep in mind as well. Okay, let's talk about briefly before we move here, because this is a very, very important part I don't want to skip over, how you write arcs, like off to the side, okay? You can kind of see down here, they're talking about arcs, but see how this one's written with 2 letters and this one's written with 3? Let me show you how that works. So let's say I said, and you know what, let's give some points to these so this makes more sense. So I have point A. Let's call this one point B right here, and this one point C. And let's say I wanted you to define this arc. Let me actually highlight it. Let's do a different color. I want you to define that arc. So we have 2 types of arcs. There are minor arcs and there are major arcs. Minor arcs are smaller ones. Major arcs are big ones, okay? How small and how big? Well, if you look at, this is half of a circle. Any arc less than that is a minor arc. If it extends past half of a circle, like maybe all the way to here, that would be considered a major arc, okay? So you can think of a minor arc as being less than 180 degrees, and a major arc would extend past the 180 degrees. So this is how we would write these here. If I want to define this arc that I drew, I would call that arc BC. So BC, and I would put an arc symbol above it. And if I'm talking specifically about the measure of arc BC, I would put a little m in front, okay? So just naming the arc would be arc BC. If I say find the measure of arc BC, I'd put the little m in front of it. Now let's give it one more letter. Let's see, let's call this point here, let's call this point D. And now I want you to try to define the major arc that would go from B through C and end at D. Now you can't just call that arc BD, okay? Because if you say arc BD, think about it. You could be talking about this arc BD, or you could be talking about this arc BD. How do you know which one? Well, if you give it just 2 letters, they assume you're talking about the minor arc from B to D. The way you define the major arc, the bigger one from B to D, is by naming it by 3 letters. Okay, so if we wanted to do that, we would actually call that the measure of arc BCD. So you'd start with B, go through C, end up at D, and you put the arc symbol above it. Okay, so just a little notation there, and that's all the vocab you're going to see throughout this worksheet. But I wanted to dedicate a decent amount of time to that, because if you don't understand that, some of this down here is going to be a blur, okay? So I'll probably end up splitting up this video into 2 videos because I really want you to get the foundational stuff done, and then we'll leave the second half for more bonus content. Okay, let's jump into some of this stuff over here. All right, let's define what a central angle is. So first off, a central angle is an angle with its vertex at the center of the circle. Vertex at the center of the circle, and its 2 sides are, you could say radiuses, but the way we pluralize radius is saying radii. I think that's how you spell it. Multiple radiuses. Okay, so let me show you in the picture over here what they're talking about. They drew you an example of a central angle right here, okay, where the vertex of the angle is the center of the circle. And then see the sides that make up the angle, those are each a radius of the circle. And that is just what a central angle is. Now, technically, in this picture, you have two of them. This is a central angle, and also this is a central angle. It's just a much bigger one, okay? And I will say, FYI, all the central angles added together comes full circle. It's going to equal probably what you're thinking. It does equal 360 degrees. Okay, so let's go back over here. So it says, for example, blank is a central angle in circle B to the left. So this is a good reminder of how to write our angles. So we would say angle ABC is a central angle. Angle ABC is a central angle in that circle. You could also call it angle CBA. I just like to put the letters in order, but either way would be acceptable. And it does say what we just talked about here. The sum of all central angles in a circle is always 360 degrees. And this says the measure, okay, this is an important part. This is why I think central angles are the easiest. It's this part right here. So it says the measure of the arc formed by the endpoints of a central angle is, and I'm going to fill this in and then explain it, it is equal to the central angle. Let me show you what that is saying. It's really simple, y'all. If you have a central angle and they tell you that angle is, for instance, 84 degrees, like we have right here, locate the arc that's formed by the endpoints. So from A to C. So if your central angle is 84 degrees, the measure of that arc is also 84 degrees, okay? So all the arcs added together we know also equals 360 degrees, just like all the central angles added together equals 360. And that is why central angles are usually the easiest to work with. Inscribed angles have a different relationship, but these ones are the exact same measure. Okay, so we can probably fill this out now. So the measure of arc AC is what we just filled in. Well, that would also equal 84 degrees, like we just said. Now they want you to find also the measure of arc ADC. So careful when you locate that arc, ADC. That means you start at A, you go through D, and end up at C. So what would be the measure of this big arc right here? Well, there's a couple ways you could find it. I think the easiest would be, if you know this is 84 degrees, and it all adds to 360, let's just do 360 minus that 84 part, which is going to give us 276 degrees. So 276 degrees. And if I labeled that over here, that means from A all the way around to C is 276 degrees. You could also say the angle from here to here, that big angle, is also 276 degrees. Okay, so hopefully that makes sense. You know everything in order to solve the rest of these problems now. Now, I will say they do progressively get a little bit harder, and you do have to use some prior knowledge that you've learned. Okay, whenever you guys get to your circles unit, it is typically taught towards the end of the year because you have to use a lot of stuff you learned in the past, like linear pair, supplementary, complementary, all kinds of stuff about triangles, believe it or not. So circles can be a bit of an overwhelming unit, but one thing I want you to look out for that's very helpful, look for your straight lines. Like for instance, in number 1, I know I have a straight line. Those are helpful because you know straight lines measure 180 degrees, so you can always find missing angles using that property of like linear pairs, the fact that those have to add to 180. Also look for any straight lines that intersect each other, like this line intersects this line, because you get vertical angles that are formed. Remember that? That means right here and right here, those are vertical, meaning they're the exact same measure. And then if you find this one, then you automatically have the measure of this one because those are going to be the exact same measure. So look for your straight lines and look for vertical angles, so intersecting lines. Okay, let's take a look at number 1. It says find each angle and arc measures. All right, and they've got three things over here they specifically want us to find. So they want us to find the measure of arc ST. That's how you would read this, the measure of arc ST. Well, that's going to be our easiest one, right? Here's S, here's T. We do have a central angle right here, 122 degrees. So that's also going to be 122 degrees. Let's label it over here. Darker blue. 122 degrees. Okay, easy. How about the measure of arc RS? It's a little bit more challenging. Let's locate it. Here's R, here's S, so we want this arc. Well, if we can figure out this angle right here, then we'll know the arc, right? Because we know that those are going to match. Those are going to be equal. So we just kind of talked about how we find that measure. So because these two angles go like this, these two form a linear pair, meaning they're on a straight line, they got to add to 180. So let's take 180, subtract off the 122, so 180 minus 122, and that's going to give us a remaining 58 degrees. If I fill that in right here, this little angle would be 58 degrees, which means the measure of the arc we're looking for is also 58 degrees. Let's fill that in over here. Okay, and then we got one left. Wants us to find the measure of arc SRT. Okay, SRT, let's locate it. So that means we start at S, we go through R, and we end up at T. This would be a major arc, right? Because it's bigger than half the circle. Okay, so think about how you could find that. Well, you know this part of it is 58 degrees. What about there's multiple ways to do this, y'all. What about the angle from here all the way to here? That's half a circle. So all that's 180 degrees. So you could add 58 plus 180 and you'll get that whole arc. Okay, do y'all see that from here to here is half the circle? So that's 180. Another way that a kid suggested in my other group, which I thought was really smart, is he said, why don't we just take 360, the whole circle, and subtract off this part that we don't need? And you could do that too. So however you want to do that. I kind of like that actually. Let's do 360 and subtract off the 122. So that, or you add the 58 to the 180. But you'll get the same thing regardless, which should be 238 degrees. Let me write that here, 238 degrees. All right, good. Let's try number 2. Like I said, they'll progressively get a little bit more challenging, and there's multiple parts to this. This is why I only put 3 problems on this side. So yeah, let's try number 2 here. Okay, first thing they want us to find is the measure of arc JK. Well, we know that's going to start easy, right? Here's J, here's K, here's our arc. We know that's going to be the same as the angle, so 21. I'll even label it 21 degrees. Okay, next up, we want to find the measure of angle JNM. So not an arc right here, but an angle, JNM. Let's locate that angle carefully. So that means we start at J, JNM, yeah, start at J, go to N, end up at M. Do you see the angle that's creating? That's this one right here. Okay, so that's like being really good with locating angles. So that's a little skill set in itself, but this is the angle they're wanting you to find next. So think about how you could find that angle. Let me put like a green line right there, that angle. And this is where I say, really look at your straight lines. I'm going to focus on this straight line in particular, okay? Because I know this angle plus this angle next to it, all on that straight line, have to add to 180. So I can take 180 and subtract off 21, and that will leave me with this missing part. Let's write that. We're going to do, to find that green part, 180 minus 21, which is going to give me 159 degrees. So that is this angle here, 159 degrees, and I'll write it over here. I'll go ahead and be consistent and do it in blue over here, 159 degrees. Okay, let's see if that helps us find the rest of this stuff. Now it says, find the measure of arc KL. Okay, it's an arc, starts at K and goes to L. So we want the measure of this arc. So think about that. So some connections you could make here. We just found this angle, which means it's the same as this angle. which means this angle is the same as this arc. So all of those things I have highlighted are each 159 degrees. Okay, so we got that one, 159 for that one as well. All right, let's see what else we've got. The measure of arc, you know what, I guess I could label this too. Let's see, this is the same as that one, and then from here to here is 159 degrees. I'll label it in here. I'm just gonna label everything because maybe it'll help us when we look at the picture. Means we know this one to also be 159 degrees. Okay, yeah, labeling your picture can be really, really helpful. And you know what, if you want, we could actually label this angle and this angle the same. Like this is gonna be 21 degrees, which I might as well label this part of it also as 21 degrees. So we've got a fully labeled picture where we found everything so that we can easily finish this up, hopefully. Okay, so we've got the measure of arc, JKM. Carefully label that one. Starts at J, goes through K, and it ends up at M. Well, since we have everything labeled, y'all, you could actually look at all of the parts and add them together. So you could do 21 plus 159 plus 21. Okay, or if you want, I mean, there's so many ways to do this. Let me unhighlight that. From here to here, you could also think of it as like, we'll take the whole circle, 360, and just subtract off 159. Either way, however you want to do that. I'll go ahead and do that way. 360 degrees minus 159 degrees. And that's going to leave me with 201 degrees for that arc. All right, there we go. Okay, last one of this one, and we got just one more problem. Let's find the measure of arc MKL. Okay, MKL. So we start at M, we go through K all the way to L. That is like almost the entire circle. Can you guys see that? So you might think on this one, why don't we do 360 and subtract off this little missing piece? That's probably going to be the easiest way to do that. So we're going to take 360 and subtract off 21. And that is going to give us 339 degrees. 339 degrees. Okay, good. Hopefully this is making sense. The last one we're going to do, you can tell, is a little bit trickier because instead of giving you just numbers, we're giving algebraic expressions here, okay? If you end up going the like honor route or pre-AP route, they will quickly get into problems just like this. The on-level route will do problems like this as well. Pre-AP, we'll just do more of them. So number 3, the good thing is they just want us to solve for x here. So let's do it. See if we can figure out a way to set up an equation here. And that is the best thing you want to do when they give you a picture and they just say solve for x. You want to look at the things that they give you, like the numbers you see, and see if you can come up with a logical equation to make. Now, the mistake a lot of kids make is they say, well, can I just take this and set it equal to that? Think about that. Look at what those things represent. This thing represents this entire arc. This thing, 26, represents this little arc. Are those arcs equal? Well, no. This one's really, really big, and this is really, really tiny. So do not set these equal to each other because they are not equal. But let's try to figure out a way maybe to relate them to each other, or find another piece of the circle, which if you notice, we do know this 26 degrees is going to be equal to this angle. So the angle is 26 degrees. And then let's use our knowledge of straight lines like we've done before. Let me highlight this one because I know I can always find an angle next to that one because they have to add to 180. So let's do 180 minus 26, which is going to give us, what is that, 154 degrees. So now we actually do know this angle, and it's going to be 154. Okay, so maybe you see how we can make an equation now. So we couldn't set this equal to this because they weren't equal, but can you see now that we can set this equal to 154 because that arc does equal that angle. So that is a logical equation. Let's do it. So the math we are doing is 15x minus 26 equals 154. And now we solve for x. So we're going to add 26 to both sides. I guess I can show my work, right? We're almost done. All right, bring down my 15x, and that's going to equal, what is that, 180? Yeah, of course, that makes sense. And then we divide both sides by 15, which should go in evenly 12 times. So x equals 12. Boom, and they're not asking us to find anything else, so that is our final answer for this part. X equals 12. Okay, hopefully that went well. I would take a pause there. Like I said, I'm going to consider this side bonus. If you want to do it, go for it. Otherwise, I would break right here and go try the practice sheet. If I look over at geometry practice, oh, this is not set to the right one. And this one's partly filled out, but let's look at it. Let me erase some of that. Looking at the practice sheet real quick, I did include 13 and 14 to be bonus ones, FYI. The ones I want you to focus on would be 1 through 6, okay? Starting at number 7 involves inscribed angles, which you can try, but you'll have to watch the other part of the notes. All right, hopefully that went well. I will see you guys next time. Okay, if you stuck around for the bonus content, aka part 2, let's get into it. So we've covered central angles. We got a good handle on that. Now we're going to look at a different type of angle, an angle within a circle called an inscribed angle. Okay, you can already see in the picture how this is different. Let me explain it just by showing you this, and then we'll fill in the blanks and give an actual definition. So central angles, we know, have endpoints on the circle, but their vertex is at the center, okay? Now you can tell, like this one, instead of the vertex being here at the center, it's pulled back all the way to the edge of the circle. This is an inscribed angle, okay? So they have endpoints on the circle, and their vertex is also on the circle. So like on the edge of the circle, all right? So let's fill that in over here. An inscribed angle is an angle with its vertex on the circle. That's right, on the circle itself, with two sides that are, you could say, also on the circle, or you could even say that the two sides are chords with our new vocab. They are chords of the circle. Okay, so that means, remember what a chord is. It's just a line segment where it's both its endpoints are on the circle. Okay. Let's look at this next part here. I'm defining something called an intercepted arc, and I will show you what that is. That is the arc that's in between the two endpoints. Okay, we call it an intercepted arc. So an intercepted arc is the arc that lies between the endpoints of an inscribed angle, just that. All right, now let's get into how to find the measure of an inscribed angle. It's not as simple as a central angle, but it's still pretty easy, I will say. So, okay, let's look at this angle over here real quick. So let's say, I'm gonna give this, let's say the arc, let me just show you an example. Say I tell you the measure of the arc is 50 degrees, okay? Well, if I said, what's the measure of this central angle that has those endpoints, you'd be like, well, that's easy. That's also 50 degrees, okay? That is not going to be the case for the inscribed angle that has those same endpoints. And if you look at it, you can kind of tell it's not the same angle measure as this. This is a bigger angle than this guy right here. Okay, maybe it's not so obvious, but if you look at it, you can kind of tell. When you pull the angle all the way back, it makes it skinnier, assuming they have the same endpoints. And in fact, it makes it half the measure. Okay, so to find this angle, you locate the intercepted arc, which is 50 degrees in this case, and you divide it by 2. So that angle would be 25 degrees. Let's go ahead and use that as our example here. So label the 50 degrees on your paper, and this angle, which would be angle ABC, here's A, here's B, here's C, would equal 25 degrees. So it's not as simple as the central angles, but it's still not too challenging either, because you're just locating the arc and dividing it by 2. And just to give you a heads up, they will go in reverse sometimes, where they tell you the angle is 25 degrees. So what would be the measure of the intercepted arc? Well, just go in reverse, right? You know, if you're given the angle, you just double it to get the big arc. So again, be 50 degrees. All right, so that probably explains everything that's over here. Just make sure you have the notes over it. So it says the measure of the inscribed angle is equal to half the measure of its intercepted arc. Okay, and just with that knowledge and everything else you've learned about both circles and some other things with line segments, you should be able to do these example problems. And I said I wanted to eliminate this part. I just don't think it's necessary right now. And I don't want you to be on information overload with circles either. So let's deal with just this inscribed angle definition and answer the questions. Okay, number 1. Find each angle and arc measures. This one wants me to find specifically the measure of angle WXY. So let's locate it. W to X ending at Y, that defines this angle. So this is going to be the easiest type of problem, right? You're just going to take 62 degrees and divide that by 2. So what's half of 62 degrees? That would be 31 degrees right there. And that's your answer. Pretty easy. Okay, let's see if we can make sense of number 2. So this one right here is a little bit different because you're going to have to go in reverse. They give you an angle, and I want y'all to recognize that this is inscribed. Let me prove it to you. You've got endpoints on the circle and the vertex also on the circle. So if I highlight where that angle is, it's right here. And look where its intercepted arc is. It'd go from D through G all the way to F. This would be what we call a major arc because it's a large part of the circle, bigger than half of it. Okay, and it does want us to find the measure of arc DGF, what I just highlighted there. So we got to think in reverse now. If you're given the angle, you're going to take it and double it to get the measure of the big arc. The arc is always going to be bigger than the angle, twice as big. Okay, so if you want to record the math that you're doing here, you're taking 113 and multiplying it by 2, which is going to give us 226 degrees, and that would be the measure of that big arc. And if you wanted to show work so you can look back at this later, you could show over here what we did just to have some good thorough notes. We took that 62 degrees and we divided it by 2 to give us the 31 degrees. Just FYI. Okay, so hopefully those basic ones make sense. Of course, they're not always going to stay that basic. They're going to get a little bit more challenging. Let's take a look at number 4. I only gave you 2 of them. All it wants you to do is solve for x. So we know when it says that, we have to somehow create an equation involving the stuff they give us. So let's make sure, this is when you have to have a really good conceptual understanding of the angles and the arcs, and then you can write a logical equation. So they give us the measure of this arc, which we know, since this is an inscribed angle, you could always take the arc, divide it by 2 to get the angle, okay? In fact, that might be a good way to do this. Let's start with that. Let's take 158 and divide that by 2. Let's write this off to the side. 158, let's cut it in half to get the angle. That's going to give us 79 degrees. So we just solve for the angle. The angle itself is 79 degrees. Awesome. It's not asking you to find the angle though. It's asking you to solve for x. But now we can actually make an equation to do that. Okay, I have it kind of covered up. Let me erase that part. It's showing you that it's pointing like an arrow to this angle, that angle equals 8x minus 9. And we also know the angle literally equals 79 degrees. We can set these 2 things now equal to each other to solve for x. So we're going to do 8x minus 9 equals 79. And then that is what we're going to solve, which I'm confident y'all can do. Let's add 9 to both sides. We get 8x equals, that's going to give me 88. And then we divide by 8. So we get x equals 11, and that's all they want us to find on this one is just solve for x. So usually you'll find the algebra is the easy part. The geometry is analyzing it and setting up a logical equation, and that is always going to be the toughest part with these problems. But we did it. We just need extra practice. Okay, let's try out number 5. This one is similar but different, right? On number 4, they give you the big arc. On number 5, they don't give you the arc, but they do give you the angle. So we could do it in a similar way. Think about this. If we're given the angle, which we are, how do we work in reverse then? Let's see, here's the angle. How do we work in reverse to find the intercepted arc? Here's our inscribed angle, if you couldn't see it, and there's the arc. Well, we know the arc's always bigger than the angle. So to work in reverse, we take our angle and we multiply it by 2 or double it to get the measure of the arc. I think that's a good way to approach this. Let's write that down. Let's take 67. Let's multiply that by 2. That's going to give us 134 or 134 degrees. And that 134 is the arc from here, from here to here. Which again, it's not saying solve for the arc, otherwise we'd be done. It's saying solve for x. Well, we do have an expression that arc represents, right? This 4x plus 58. But we now know the actual measure of the arc is also 134. So we can set this expression equal to 134 degrees and solve for x. So we're doing 4x plus 58 equals 134. Okay, let's go ahead and solve that. So we know we're going to subtract 58 from both sides. These are going to cross out. We get 4x equals 134 minus 58. What is that? 76. And then from there, we are dividing both sides by 4. And totally fine if you're using a calculator for the computational parts of things. Most teachers will let you do that. And that's going to give us x equals 19. And we're done. So that was the bonus round. Honestly, it's not too challenging. I just didn't want to overload you with content. But now if you go to your practice sheet, you should be able to get through, starting at number 7, the rest of the way down the page. Now they do get a little bit more challenging, so you might want to look at the practice video for some of these ones right here. But definitely try it on your own first. All right, good job, you guys.